Hello there, welcome to AFS Log. In this part, I would be talking about the shape library. So there are cases whereby you would need a basic shape to cut out, and you don't really need to go through the hassle of design using CAD. You can just run through the pre-designed shapes on the console. I believe all CNC machines come with preloaded shapes, basic shapes. So we get into shape library, and I would want to be working with this today, so I can either select using F6 or enter. Okay, now we can get right into modifying the parameters of the shape. Let's start with F1. It shows all the preloaded basic shapes on the console. You can move with the arrow key to select whichever you want. Then you input the parameters following a guide that is shown below the screen. The diameters, the radius, the length, the breadth, the size, everything. Then when you are done with inputting your own specific parameters, then you click on F7, which is OK. Now, if you click enter, it will not work. You have to click F7. Click on F7. Okay, so let's start with how to go about our cuts. Okay, let me mention something very important concerning the shape library, since we are not programming manually from the CAD software. Now, I would not talk about the sizes because they are already indicated here. This size 1, 2, 3, and 4. So they are all here. But I would talk about the norm, and the leading lead out. The norm for this kind of shape is asking how many of the internal features do you have. Sorry, the number of the internal features that you need. So if I change this to 8, and I go to the next one, you see, you have 1, 2, 3, 4, 5, 6, 7, 8. So that's for the norm. Now, the leading lead out, very important. The leading lead out is when you want to start taking your cuts and the machine wants to start piercing. The leading is, can I call it, just as it states, leading in into the cut, the main cut, which you can take from the external part of your main shape, a part that should not be affected, that you do not need. So if you look at these features, you will realize that their lead in and lead out are internal because they are internal features. And the leading length and lead out length must not exceed the length or the size of your internal features. What am I saying? Now, the internal diameter of this main diameter, that's size 2, that's the radius of size 2 states that it is 15. Now, so since it's 15, so 5, it's okay. Now, if I increase the leading to 10, you realize the leading goes a bit bigger. Now, if it exceeds a normal size, it will, if it exceeds or If it gets too much close to the size of your main feature, it will affect your feature, your cut. It will cut into your design, to cut into your desired output, your main shape. And we want to avoid that by all means. Good. Of a standard, mostly I use leading size of 2 or 3 millimeters as the leading. So, and also you should always indicate your leading should be internal in your internal features. The leading and leader should not be external. It should not affect this part of the shape. It should be internal, since this can be cut out and discarded. So your leading and leader should be internal. Now you get the point. The internal features leading and leading should be internal. The leading and leading for the external main part or cord should be external. So then, okay, it brings your shape. Now for instance, this square, okay, this is what I was trying to look for. So I guess it doesn't work for the circle features. Now this is the square features. The same principle applies. And now if I try to do something like this, as okay, look at this. This is bad for a cut. That means it's, if this is the main shape I'm intending to use, I'm not probably I'm cutting it as an internal feature. I'm cutting it as the main shape. This is bad. But if I'm cutting it as an internal feature for a shape, this is good. Right. That'll be that. But that's, we're taking too much time on this already. So from here we can come to the files part. The files is where you read. Now all these are the names of the preloaded files, the shapes library, the files, the shapes we saw in the shapes library. These are the shapes. So, but we don't need to talk about them now. But rather, if I select USB, you can read the files on my USB flash drive. I notice that this console can only read the file in a one-step folder, not a sub folder, just a single folder. So if I open the flash drive, I can go into a folder like recall and I will see the files. But if I have another folder in this folder, I don't know why, but it will not read. So that's how you go into your USB and then you press escape to go back. I'll be taking you on a journey to making a lock guard for this component here. Is meant to be for the inlet of a cubic tank. So how I plan to do this is to make a flange here. So a flange will come here and have a hole in between it. Then this covering, threaded covering, is also going to have another plate attached to it, welded to it on the top, extruded out, and it will align with the flange on the body, on the cylindrical body, and both we have a hole that can be locked through with a padlock or something. So this is what we are trying to do. Now we're going to be programming this on the CNC Plasma machine all by ourselves. Alright, no design will be used, so I'm going to use a template from the machine. So let's get to it. I'm going to be cutting through a 5 plate for this. I come to Shape Library. So the first one, we are going to cut the top plate. So the top plate for the covering is going to be about alright, so from here to here, let's make it I think 70 is okay to give enough space. Yeah, 70 is okay. 70 mm. So now coming to the console. So as you can see, I can select whichever shape I intend to use. And this is exactly the shape we want, shape 40, right? So click on enter. So the parameters, right? The parameters we want to use, will be 70 by 60. So it should be a bit wide enough. 70 by 60 is okay. Yeah, 70 by 60. So which means the length will be 70. Yeah, it says 2 is the length. The width will be 60. And that is 1, as you can see. The diameter should be about 15. I think 15 should be okay for the padlock to be able to go through. I'm guessing they'll be using a big padlock. So the diameter should be 15. 15 is good. 15 is fine. So, but here they talk about the radius, which is number 3. So number 1, which is the width, we have 60. So, sorry, that's wrong. Yeah. I include size 2, which is the height, 0.70. We come down. Size 3, which is the radius. Since we're thinking about 15 for the radius, I mean for the diameter, so 7.5 is okay for the radius. We put 7.5 for the diameter. You notice it's changing. So here we are going to find a way to centralize it. That's size 4. Find a way to centralize it. So the spacing will be the division of the two sides divided by 2. That will be 160 divided by 2. So it should be 30. It's not giving the right value. So it should be 30, right? But we subtract the radius. 30 minus the radius, 10.5. So we have 22.5. So let's try 22.5. Correct. Correct. So we have it in the middle now. So number 5 is the distance between here to here. So we just want an offset of about 20 from the top. Yeah, an offset of about 20 is okay from the top. An offset of about 20. So which means from here to here should be 20. So we already know the full length, which is 70. Then minus 20 and minus the diameter, which is 15. So that is 20 plus 15, 35. Then we say 70 minus 35. But let me see if that will be correct. No, it's too close. It's too close. Should be around here. So let's do it 15 then. So here to here should be 15. Here to here should be 15. Plus the diameter should be 10. Here to here should be 10 plus the diameter 30. That's 40. Alright, so 70 minus 40 would be 30. So 5, let's select 30. 30, right? I'm not sure if it's going to give us what we want. Oh, no. Okay, let's select. We brought it to the middle, so we don't want it in the middle. Let's take it to 40. And I think it needs to go a bit more. 45. Alright. Okay, it's okay. Yeah, I feel it's good. So 45, it's good. 45 is okay. Alright, so now the leading lead out, I usually love to use 3 mm for my leading and lead out. It's okay for the flare of the plasma not to affect our main cut. So yeah, you notice the leading lead out are not smaller and they are looking good and better. So we press F7, which is okay. We're done with our programming. Now down to the main programming, I would input the main parameters of what to be used, and that will be for the speed, cut speed, and for the parameters of the initial I time, the PS height and the PS time, plus the arc voltage, which is on the inverter, so which controls the current. So first, for a 5 mm plate like this, I already made some cut on it, so it's 5 mm. For 5 mm cut, I would usually love to use current set to about 45 amperes. For me, I think it's good and safe to have a clean cut with that kind of amperage, and also I'm using quite an old nozzle, but to do the job efficiently. So for 5 amperage, you can see the air pressure is active and the power is on. You must always check for the air pressure. If it is not active, it will not work. So then back here for the speed, the cut speed, which is F. For 5 mm, I love to go as slow as 600. So I believe it's reads in millimeters per second or thereabout. So I go 600. For 3 mm, at times I go 800. For 2 mm, I think at times I go about 2000 for the cut speed. For 1 mm, I go about 2500. And for 0.5 mm, I go about 3000. Yeah, so that is that. Now for the initial I time, I use 4, and also here I use 4 for the PS time. Also both work hand in hand most of the time. So for 5 mm, I use 4. That's like, I mean, not 4, 0.04 seconds, 0.04, 0.4 seconds, 0.04 seconds, 0.4 seconds. Then the PS height, that's the height it takes for, and the PS time is the time it takes for the first PS. Immediately it makes the first PS, and then it waits before start moving for the cuts. This is the PS time. Now the PS height is when it makes the first PS, the burst of the plasma, it moves back up before it starts moving for the rest of the cut. This is the PS height. So here I usually use 0.7, I mean 0.07, 0.8. Let's use 0.07. For 0.5 plate, I use 0.07. Now for the output, this also controls this at times. So when the arc volt, this is the voltage, this is the amperage, this is the arc volt. I think earlier I said this is controlling the amperage. This is controlling voltage, not the amperage. So for the arc volt for 5 mm, I use 108 to 110. So let's leave it at, okay, 110, since it's 5 mm, 110 is good. The reason is because the more the arc voltage set and the higher the amperage, both work hand in hand, the higher your nozzle goes when making the cut. And it's good for your nozzle to actually kind of move up a little bit while making the cut, because sometimes your plate might be budged, and when it's budged, it kind of obstruct the movement of the nozzle. Like if you notice, the 1 mm on the plasma bed is kind of budged. So let's go on. I believe we are good to go with that setting. Now when I start making the cut, you realize that it makes the internal cut before making the external cut. So let's measure from where we want to start cutting. I want to use a space around here for my cuts. So we have 70 by 60. That will fit in perfectly. So this is to raise your nozzle up manually. This is to bring the control the y-axis. Now I want to take my origin, my reference origin. So this reduces the manual speed. This reduces the manual speed. I'm done with this. I need to do what we call a framing to see a scope of what I want to cut. So I increase the speed just a step. Then I click on not manual move. Then I want to frame. Now notice X and Y has this not at 0. They are meant to 0 since that is the origin I want to set, but they are not on 0. So I can either 0 off here, F3, or I press frame. If I press frame, it will 0 off automatically, right? Alright, so and immediately I press frame, the machine starts framing the position. Alright, so exactly, so that is where I want to cut from. So I proceed with my cut. Let's go, and hopefully it comes out well. Alright, so it cuts the middle first. Now if you notice something like this, when you want to make your cuts that the plasma is not coming out well, you raise your nozzle up. So it makes the middle cut first, make the nozzle up, then it moves. So if you notice, let me show you guys something. If you notice, the speed at which it's moving is quite slow, which is good, and it is cutting through. But if I want to increase the speed, cut speed to about, let's say 2000, it's gonna be very bad. Now watch this. That is bad. Look at that. It doesn't cut through. So I bring it backward. Then we come back to change the speed back to 600. Right. So now it cuts through. Yep. So the speed is very important to take into consideration when cutting. Very, very important. So we have cut successfully. Alright. So it stops. I can says to home. I can press escape or press OK. Either of the two. I want to take my nozzle back. Alright. Then this can fall in. Yep. Of course, I take my glove. And we have quite a very clean cut, I believe. Yeah, I think it's clean enough. So this was where, ouch, it's quite hot. I think, was it? This was where, oh no, okay. This was the leading and lead out, I believe. So that's where we have that rough cut over there. But it's beautiful for 5 mm. Yeah, so see you guys in the next episode. Yep, we are here again for the second part. So we go into the shape library and we want something like this, right? We want something like this. Yeah, but first we have to create the hole in the middle. This shape does not have a hole. It's meant to have a hole somehow in the middle. Then enter, give it 7.5, choose the half of 15, 7.5. The leading lead out, I don't need it. I don't want to lead in, so sorry, what did I just do? Oh, sorry, that would be 0.0. Leading it out, no leading it out. Correct. Yeah, 15. Let's do this. Let's do it. 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 Oh, that's better. Now, I go back to the shape and choose the shape we wanted to use for the cylindrical part of the component. Remember our height, which is our width, which is size 2, is 60, and our height is 70. Correct. The leading, you can leave it at 3, leave it at 3. Yep. So, okay. Now we have to position in such a way that there will be a gap between this and this. So we have, let's say 10 mm, they're about 8.5, and we have 23. Now go back and try to measure from here. I have to get about 8. So I need 8.5, yeah. So just come closer, 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 closer. So just to bring it a bit closer. Yep. The speed. Let me check the speed. 1,200. It's okay. So to bring it a bit closer. Alright. Remember, there's a leading lead out, so yeah, I think it will suffice. And here we have 8. The 8. Here we have all we want, right? We have 22, 22.5, 22.5 from here. So, no, that should suffice for the leading lead out. Cool. Let's hope this works. Now, this is not trial and error stuff. It's not guesswork. I'm just trying to work with numbers. Alright. But because I don't have the shape that I really wanted, like the one having a circle in the middle, so I had to go through this way. So I frame first, so it zeroes off from there, and then it moves the direction I want it to. Cool. Now we can start. Yep, have it right there. Take the nozzle up. Escape, otherwise you won't be able to move the nozzle back. Then move the nozzle back. Increase the speed with the nozzle back. Correct. Yep. Oops. Oopsies. I hope we got what we wanted. I honestly hope we got what we wanted. Alright, let's test this out. Check this out. Test this out. Check this out. Okay, this is post cleaning. Slugs is removed, and yeah, it's not really at the center as expected, but maybe it works. Maybe it doesn't. See, it doesn't. But what we're going to do is cut a bit off, just to sorry, just to get the radius of the curve that we want. And this is still because of the fact that I could not manually edit this curve. So check this out. So yeah, I think it's cool. Yeah, I think it's cool. It's cool. It's cool. It's cool. So just need to cut this guy off. All right. And so I believe that will be all. Thank you all for watching. See you guys in the next one.